Hello everyone and welcome to this video on the Python programming language. So in this video I'm going to create a Python program for cryptocurrency analysis. Now currently I'm on Google's website called colab.research.google.com because it makes it really easy to start programming in Python. So all you have to do is go to this website and then log in using your Google account and get started writing your Python code. So let's go ahead and get started writing this Python code. Now the first thing that you're going to want to do is click on File and then click on New Notebook where a new tab will open up for you. And before I write any code, I like to put a description and comments about the program. So I'm going to do that now. I'm going to type description and let's put a description of this program. So this is a Python program for cryptocurrency analysis. All right. Now I'm going to create a new cell by clicking this code button in the top left here. And in this cell, I'm going to import the libraries that I know I will need throughout this program. So I'm going to import NumPy as NP, and I'm going to import pandas as PD. And then I'm going to run this cell by clicking this button here, and it's going to let me know if I made any errors. Okay, so everything looks good. I'm going to go ahead and create a new cell. And in this cell, I'm going to load the data. So I'm going to use Google's library to do this. So from google.colab, I'm going to import files, and I'm going to create a variable called uploaded and set it equal to files.upload. Okay, and let's run this. Now let's choose the files that I want to upload, which are 3 CSV files that contain 1 year's worth of data for Bitcoin, Litecoin, and Ether. So let's go ahead and open those files. And I got these files from coindesk.com or coindesk.org, but it's from Coindesk. Um, anyways, I have those files, and actually I will put a link to the site in the description below so you can also download these files yourself. All right. Okay, so anyways, we have our 3 CSV files uploaded, and let's go ahead and create a new cell. All right, now in this cell, I want to store the data into DataFrames. All right, so I'm gonna create a variable called df_btc, and I'm gonna set it equal to pd.read_csv, and we're going to read in the Bitcoin CSV file. So that's right here. I'm going to highlight it, and then I'm going to copy it using Control C, and I'm going to paste it in here using Control V. Next, I'm going to just copy this and paste it about 2 more times. And I'm just going to change the variable name up a little bit. So instead of BTC here, I'm going to type ETH, and we're going to get the ETH_USD 2019 322, that whole file name. And I really could just copy it here, but all of the file names are the same except for the first 3 letters, right? So anyways, I'm just changing up the variables here and the data sets that the variables are reading. So we have df_btc, df_eth, and now this right here will be df_ltc. Okay, and this will be LTC here as well, and that looks good. Okay, so I'm going to go ahead and run this cell. Okay, and now let's go ahead and create a new cell, and in this cell I'm going to print the data. So I want to print df_btc, and I want to also print ETH and LTC. So I'm going to just paste this 3 more times, and let's make this LTC, and let's make this one here ETH, and let's run this cell. Okay, so now I can see all 3 data sets. Okay, so that looks good. I'm going to create a new cell, and you all have not seen the data set and all of the columns in it, right? Because here, when I'm printing the data sets, it's not really showing all of the columns. So actually, instead of me printing the data like this, let's show the data like this. I'm going to just get rid of that. Let's run that. We're running the BTC data set here. And actually, I'm only going to print the first 5 rows of data. All right, but we can see these columns here for that data set. And I'm going to do the same for the other 2. I think this right here would be a better way to take a look at the data set. So here I am going to print the first 5 rows of data for Ether, or ETH for short, right? And here we're printing the data for Bitcoin, or BTC for short. So let's run this cell. All right, and now we can see the first 5 rows of data for Ether. And last but not least, we're going to do the same thing for Litecoin. So here we're going to print the first 5 rows of Litecoin, or LTC for short. So df underscore LTC dot head, and there we go. All right, so I think that actually looks a lot better than how I wanted to print it originally. But now we can actually see the columns, and we can see some of the data for each of the columns. All right. Now let's go ahead and create a new cell. And in this cell, what I want to do is I want to take the closing price of all 3 data sets and put them into a new data frame. So here I'm going to create a new data frame that holds the closing price of all 3 cryptocurrencies. Okay, so I'm going to create a variable called df and set it equal to pd.dataframe. And let's see, we're going to give the data frame a column name. So one name will be BTC for Bitcoin, and it's going to contain the data from df underscore BTC at column closing price USD. Okay, and I'm just going to copy this and I'm going to paste it. Actually, I'm going to get rid of it. I'm going to copy all of this here using Control C and then paste it using Control V. And I'm going to do that one more time. Okay, and I'm going to get rid of that comma there. And now I want this right here to be ETH. And we're going to be using the df underscore ETH data frame for that column. And this other column will be called LTC. And we're going to use the df underscore LTC data set for that column. All right, now let's go ahead and run this. Okay, that looks good. Let's create a new cell here. And let's show the new data frame. So just type df and let's run this cell. Okay, and now we see that we have this nice data frame with 3 columns, PTC, ETH, and LTC, and all the values in each of these columns are the closing price for those cryptocurrencies. So that looks good. Okay, so now we have our data set up. Let's go ahead and do some analysis on the data. So I'm going to create a new cell here, and the first thing that I'm going to do is get some statistics. So let's get statistics on the data. All right, and actually let me go back. Yeah, that's fine. We're gonna get some statistics on this data. Let's type df.describe and let's run this cell. And now we can see some stats on the data. So I can see that the minimum value for Litecoin is $32 and about 5 cents. The maximum value for Litecoin is $139.38. The minimum value for Bitcoin is $3,913.78. Now, you also have to remember that this data is from the past year, right? It's 365 days in the past, or maybe it's 366 because it's not counting today, right? So it's from March 22nd, 2019 up until yesterday. Okay. And you can take my word for it, or you can actually examine the data sets as well and uh, see for yourself that that is the case. So anyways, we also have the mean price. So I can see that the mean price for Litecoin is $73.07. The mean price for Ether is $194.64. And then the mean price for Bitcoin is $8,414.96. So Bitcoin seems extremely expensive compared to the other two cryptocurrencies. All right, so let's go ahead and create a new cell here, and let's get a visual of the closing price. So we're going to visualize the cryptocurrency closing prices. All right, so I'm going to import matplotlib.pyplot as PLT, and I'm going to give my plot a style. So I'm going to type plt.style.use, and I'm going to use 53038. Okay. So next I'm going to create a variable called myCrypto, and I'm going to set it equal to df, to our data frame that we just created. And next I'm going to give our plot a size. So I'm going to type plt.figure, and inside of that I'm going to type fig size equals, and it's going to equal 12.2 inches by 4.5 inches. So 12.2 inches wide and 4.5 inches high. Okay, now I'm going to loop through the columns in the data set. So I'm going to loop through my underscore crypto dot columns dot values. Okay, so for C in my crypto dot columns dot values, I'm going to plot. So type plt dot plot, and I'm going to plot these price points. So I want to plot my underscore crypto at column C, because C is in those columns. So that's going to be LTC, BTC, and ETH. Okay, and then we're going to give this a label. So the label will be equal to C. All right, and then I'm going to give this plot a title. So I'm going to type plt.title, and I'm going to call it cryptocurrency graph. All right, and then I'm going to give the x-axis a label. So I'm going to type plt.xLabel, and the x label, I will call it days for now. And let's give the y-axis a label. So type plt.ylabel, and the label here will be crypto price in dollars. Okay, and then let's give the plot a legend, so we know that we know what we are looking at. So plt.legend, and then I'm going to input my underscore crypto dot column dot or columns dot values, and we're going to put it in the upper left location of the graph. So upper left. All right, now we will show this graph, and hopefully I didn't make any mistakes. So let's run this. Okay, so now we get back this graph, and you can see the days are actually numbers, so it's not an actual date, right? But I think you understand what's going on here. So these are the days. So on day 0 here, that was a year ago. That was in 2019, March 22nd. That's the point that we're starting at, and that's what this value 0 really means for days. Okay, and we can see that the cryptocurrency price, the closing price, is on the y-axis here to my left that I'm circling, and what you can also see is basically only the price of BTC, right? The other two prices, or the other two um, cryptocurrencies, seem a bit more constant, and that's because the values are much lower than that of Bitcoin. So we don't really get a good visual of these these other two cryptocurrencies with Bitcoin in this graph. But that's okay because we can change this. So let's go ahead and create a new cell. Now, in this cell, what I plan on doing is scaling the data. Okay, so let's do that here. We're going to scale the data, and we're going to do this to get a different visual. So I'm going to use another library. So from sklearn, I'm going to import pre-processing, and I'm going to create a variable called min max scalar, and I'm going to set it equal to pre-processing dot min max scalar, and we're going to give it a feature range. So I want to make sure that the data will only contain values between 0 and 100. So I will type 0 and 100 here. Okay, now I'm going to create another variable called scaled, and I'm going to set it equal to min underscore max underscore scalar dot fit underscore transform, and we're going to input the data frame, and then let's take a look at the scaled data. So let's run this cell. Name feature range is not defined, so let me see, feature underscore range, and I need to set this equal to that. So let's run this again. All right, so now we can see that we get back the scaled data as an array. So I need to change that data from an array to a data frame. So I will do that now. Okay, so here we're going to convert the scaled data into a data frame. So I'm going to create a variable called df underscore scale, and I'm going to set it equal to pd dot data frame, and I'm going to input the scaled data, and the columns for this data frame will be the same columns from our original data set called df. All right, now let's go ahead and run this, and that looks good. I'm going to create a new cell here, and now let's visualize the scaled data. So I'm going to create that variable again called my crypto, and I'm going to set it equal to df underscore scale, and let's give the figure that we're about to create a figure size. So plt dot figure, and here I'm going to put fig size equals 12.4 by 4.5, and then let's loop through each cryptocurrency and plot the close price for each day. So for C and my underscore crypto dot columns dot values, I'm going to, well, oops, my crypto dot columns dot values, I'm going to plot plt dot plot my underscore crypto at column C, and then we're going to give this column a label. I'm sorry, we're going to give this plot here a label. So label is going to be equal to C, and let's give our graph a title. So this is cryptocurrency scaled graph, and I'm going to give the x-axis a label. So plt.x label, it will be days, and then the y-axis will have a label. It will be the crypto scaled price. All right. Next, we're going to give this plot a legend. So type plt.legend, and I'm going to put my underscore crypto dot columns dot values, and we're going to put it in the upper left location of the graph, and then just show this graph. So plt.show, and let's run this. All right, let's see. Module matplotlib has no attribute phi figure, so I misspelled figure here, and let's run this cell. All right, so now we get back this nice graph, and it looks a lot better than the graph above, and immediately I can see something very interesting. So I can see that it looks like all of the cryptocurrencies are going up around this day here, some day between 0 and 50, and I can see that all three went up around here. It looks like they all kind of dropped right around here, and they all dropped right around here, and you can see this big dip here. So that's pretty interesting. They probably have some high correlation is what I'm guessing here, and is what I'm expecting. But let's go ahead and create a new cell now, and in this cell, let's get the daily simple return. Okay, so I'm gonna create a variable called DSR, which will be short for daily simple return, and I'm gonna set it equal to df dot percent underscore change, and we're gonna use the change for a day, but by default this is a 1, so it's gonna be the same value. I don't really need to put that 1 there, and let's print the daily simple return. Let's run this. Okay, so now we get back the daily simple returns, and that's all fine and dandy. But I think it would be a lot better if we could visualize it, right? So let's go ahead and create a new cell. And in this cell, I'm going to visualize the daily simple returns. So I'm going to basically do the same thing that I've done with all the other plots. Just type plt.figure and give it a figure size. So it's going to be 12, and we'll do 4.5. And then we're going to loop through the cryptocurrency daily simple returns. So for C in DSR dot columns dot values, I'm going to type plt dot plot, and we're going to plot this time. This time I put in the index. I'm sorry, I put in the x-axis. So I'm going to put the index for the x-axis here, just to kind of change it up a little bit, and to show you all, you know, a slightly different way to create your graphs. But anyways, we're going to put dsr.index, and I put dsr, the column C there. So now we're going to get the y axis. We're going to be plotting on the y axis here. So I guess I probably should have explained that for the other ones as well, but let's explain that here. So here I'm inputting the x-axis, here I'm inputting the y-axis on the plot. Okay, and let's go ahead and give it a label. So label will be C. And you know what else we can do with this? We can give it a line width. So I'm gonna set the line width equal to 2, and we can give it a alpha for blending. So we'll set alpha equal to 0.7, so you can see like how transparent it is. Okay, so that's just to kind of switch it up a little bit. Let's give our plot a title. So plt.title, and I will call it daily simple returns. That's good. The y-axis will have a label, so plt.ylabel is going to be called percentage, and this will be the percentage in decimal form. Okay, and then let's give our x-axis a label, so plt.xlabel, and I will call it days. And maybe days is not the right label for it, but that's what I'm going to use for now. And let's see, plt.legend, we're going to use dsr columns dot values, and we're gonna put it in the upper right location, and then let's show this plot. So let's go ahead and run this. All right, let's see, maybe I made a mistake somewhere. Name X is not defined. Where did I put X? I put label equals X, label equals C here. So let's go ahead and run this. All right, and now we get back the graph, daily simple returns, and you can see that Litecoin has a few spikes. You know, here the return seemed to be very high, a positive high return here for that day, and then a very low negative return for this day here, which was actually fairly recent. Okay, and let's see here. Bitcoin is in blue, and it doesn't seem like it has a big spike for its daily returns, at least not bigger than Litecoin and or Ether. Anyways, let's go ahead and create a new cell, and let's kind of take a look at the volatility of all three of these cryptocurrencies. So here we're going to get the volatility. So I'm going to print the cryptocurrency volatility. All right. So in order to get that, we just type dsr.std, which is short for standard deviation. Let's run this. And yes, volatility is standard deviation. It's also the square root of variance. Okay. So let's take a look at the volatility here. So if I take a look at the volatility, I can see that Litecoin is the riskiest of these three assets. So that's nothing that's surprising there. We can see it through all these charts. It's definitely the riskiest. What is kind of surprising for me is that Bitcoin is the least volatile out of these three assets. I I actually was not expecting this when I first um, was thinking about doing this video, and this is actually very surprising for me. So let's go ahead and create a new cell here. And now I'm very curious. I want to know what's the average daily simple return for each of these assets. So here I'm going to show the mean or average daily simple return. And in order to do that, just type dsr.mean. Okay, and let's run this. Okay, so this is equally as surprising. Bitcoin gives the higher daily return. It has the least volatility. Litecoin gives the least return but has the highest volatility. So this is not financial advice or anything, but for me, if I was going to invest in one or the other, it probably would be um, Bitcoin, just from all of this analysis so far that we've done for these three assets. But all three are very volatile, you know. So anyways, let's go ahead and create a new cell. All right, and what I observed earlier was that it seemed like there was some correlation between these assets. So let's show or get the correlation matrix, and let's see. So here we're going to get the correlation. So just type dsr.core and run this. All right. And yes, we do see some correlation. And for those of you who don't know, correlation is used to determine when a change in one variable can result in a change in another variable. So I can see a high positive correlation for all three assets, right? We can see that Ether has about 83.68% positive correlation with Bitcoin, and Bitcoin has a 77.3, I rounded up to 2, so 77.32% positive correlation with Litecoin, and the highest correlation is between Litecoin and Ether at 84.87%. Okay, so let's go ahead and create a new cell, and I like to visualize things, so let's visualize the correlation. Okay, so I'm going to import Seaborn as SNS, and then I'm going to plot this. So let's type plt dot subplots, and fixed size will be equal to, we'll go with 11 by 11, and then we're going to create a heat map or draw the heat map. So just type SNS dot heat map, and I'm going to input the correlation. So that's DSR dot core, or I should say the correlation matrix, and let's give this heat map some annotations. So type endnote equals true, and let's format it. So type FMT, and the format will be percentages with 2 decimals. So 0.2%, and that looks good. We'll just go with this. That's fine. So let's run this. Okay, and now we can visually see the correlation between these assets. Okay, so it looks good. All right, so let's go ahead and create a new cell. And I would go through that matrix again, but I think it's pretty self-explanatory here. The diagonals, of course, are when to see the correlation between the same asset, right? So LTC is 100% correlated to LTC, ETH is 100% correlated to ETH, and BTC is 100% correlated to BTC. And then really the top of this heat map is redundant. So these 3 squares are the same as these 3 squares. All right, so I think we're good on that. So now I'm curious, well, what if I had invested like $1 in all 3 of these assets a year ago? You know, how much would my investment, how much of it would have paid off? You know, how much would I've gotten back or lost? So we can figure that out right now. So all we need to do is get the daily cumulative simple returns. So I'm going to create a variable called DCSR, and I'm going to set it equal to DSR plus 1 dot cumprod. Okay, and then let's show it. So DCSR, let's run this cell. Okay, so now we get back the daily cumulative simple returns. All right, but let's visualize this, of course. So I'm going to create a new cell here, and we're going to visualize the daily cumulative simple returns. So just type plt dot figure, and we're going to give our figure a size, set it equal to, I do 12.2 and then 4.5, and let's loop through this, let's loop through the data. So for C and DS or DCSR dot columns dot values, we're going to plot the indexes. So I go with DCSR dot index, and then we need to plot the y-axis. So DCSR at column C, and I'm going to give it a line width equal to 2 and a label, which will be the column name. And then we're going to give the plot a title. So plt.title, call it daily cumulative simple return. And of course, the x-axis will have a label. So we'll call it days. And the y-axis will have a label. And I'm going to call it growth of $1 investment. Okay, and then we're going to give the plot a legend. So dscr dot columns dot values, and we're going to put this in the upper left location. All right, and I give it a font size as well. So font size, make it 10. Why not? Just to be a little fancy here. And then let's show the plot. So plt.show, and let's run this. All right, so I messed up DSCR. I'm misspelling. It's DCSR here, and let's run this. Okay, so now we get this nice chart or graph called daily cumulative simple return, and now we can take a look at what would have happened if we had invested $1 a year ago in all three of these assets. So of course we would have invested $1 here. What I immediately see is on the 100th day after that dollar investment, the price for Bitcoin, that dollar, would have been $3, and the price for Ether or actually, let me see, 100 days afterwards, it probably have been not $3, but a little bit less than $3, and between $2.50 and $3 would have been the price of Bitcoin. Now, if I look at Ether here, it looks like that dollar investment would have given me back about somewhere between $2 and $2.5, and for Litecoin, it looked like it would have been somewhere between $2 and $2.5 as well. So what that means is, if I had invested $100 in, let's say Bitcoin, I would have gotten back somewhere between $250 and $300 back from that $100. Well, not back, but my $100 would have become 250, somewhere between 250 and $300. All right, so um, that's pretty amazing. Now, something else that I did notice is that if I had invested $1 a year ago in all three, it looks like as of yesterday, I would have actually lost some money. So I would have, if I kept it in there for a year from last year to yesterday, that dollar investment would have lost me money for the asset Ether and definitely for Litecoin. For Ether, it looks like it's almost even. I can't really tell, but definitely for Litecoin. And for Bitcoin, strangely enough, I still would be ahead. So if I were to invest, into any three of these assets, it probably would be Bitcoin in this case, based off of this analysis. But again, this is not financial advice. This is just me playing around with Python and with cryptocurrency data, and this is just a learning exercise. So anyways, I hope you all enjoyed this video. Thank you for taking the time to watch this video. Please leave any questions you have in the comment section. If I don't get to them, sometimes other people get to them. And become a subscriber to my channel for more Python videos and programming in general. And if you enjoyed this video, please share it. Maybe other people will enjoy it as well. And as always, thank you all for watching, and I'll see you all in the next video.